That brings up questions of climate. There were a couple new results in Nature that I wanted to share, and the summary of the future role of polar ice. There's actually a lot that we don't know about the way in which the ice at the North and South Poles melt, and also the impacts of the result of the flowing water, the ice melt that flows into the oceans that surround them. So these papers on the left, the global consequence of ice melting, and on the right, the one about whether or not ice cliff instability is required or important for the levels of sea rise that are predicted. So this one, it talks about the way in which we see those big calving, unstable ice cliffs. And there is a debate in the community as to whether this is necessary for there to be an enormous rise, and if so, how much will it contribute to the rise, and will we see the loss, the massive loss of ice from these ice cliffs like this, as opposed to a slow melt. And so that's what this paper was all about. And this marine ice cliff instability, also MICI, you'll see two different studies that these folks did. One where there is the ice cliff, that is MICI, the ice cliff instability, and one without it. And what is the difference with regard to how much rise there is in the sea level? And you can see on the left there. So if there is ice cliff instability and the ice cliffs fall into the ocean, you'll raise the levels of the sea a lot. If not, you won't. Now, you see this RCP thing around, and I just wanted to just indicate what those numbers are. The lower the number, the earlier the fossil fuel emission peaks. So when you see 2.6, that's peaking essentially now. Clearly, we're not in the RCP 2.6 scenario. If we peak at 24 and at 2040 and then drop, that's the middle one, the 4.5. And if we continue to rise through the end of the century, that is the 8.5. Each of those different scenarios are sort of test scenarios, if you will. The climate modelers, so that everybody's comparing apples to apples, work within the context of these different scenarios so that everybody's data and results can be compared. So you can see, basically, if the ice cliffs fall, it's bad. So we're hoping that that doesn't happen, and there is no conclusion as to whether this does happen. But the good news is that the researchers were able to model the last warming period without, and the observed rise in the oceans without the collapse of the ice cliffs. So that suggests that the ice cliffs didn't fall apart in the last warming period. Maybe they won't fall apart in this warming period, and so they actually offer a rather hopeful view that we might be in those colored bands at the bottom there without a lot of sea rise, comparatively speaking. Yeah.
The sea level rise really isn't as important as the fresh water going into the ocean. There's salinity currents within the ocean.
Well, what a perfect lead up, because that's the second paper. The second paper is about the consequences, and in fact talks exactly about that, about what happens with the melt water, which, as this gentleman mentioned, does not have the salinity of seawater. And so now that is unfortunately not so good news, because this generates the way in which the currents get shut down, essentially, by this melt, traps warm water under the ice of Antarctica, and in Greenland just shuts down the conveyor belt altogether. And so you get more warming from under the ice. Basically, we've talked about in here before about the way ice drifts down through the valleys and then into the sea, becomes sea ice, and then melts. Then we've also just talked about cliffs falling in. The third way you can lose ice is from underneath, because there's melt underneath and it just wears away from underneath. And that's what this paper is talking about, and their results are that it's not so great. What I didn't know until reading this stuff was that ice melt was not included in any of the work that's been done on these models. All these IPCC models and discussions that we've had in here, they just hadn't handled, they didn't have a mechanism to handle the ice melt, and now they do. So that's what, there were actually these 3 papers in Nature all on the same subject and discussing the importance of ice melt into the 21st century. Now, we did talk a little bit about wanting, I guess it is the 21st century, isn't it? Into the 22nd century? Holy smokes.